Hi friends, in this video we are going to discuss about special questions in DC machine. In this concept, see a DC shunt motor for example. How is my DC shunt motor? It is like this. Here my armature winding. This is my back EMF. Here the armature current. Here the IL. And here my ISH. This is my DC shunt motor. In this motor, first one, if field winding open circuited, then what happened? What happens, sir? If field winding open circuited, then what happens? We know that generally option A, under no load condition, my motor operating at no load condition, if field winding open circuited. When the field winding is open circuited, nothing but the flux is equals to 0. If the flux 0, speed is nothing but inversely proportional to flux 1 by 0. So something by 0 is nothing but infinite. So if the field winding open circuited at no load condition, the speed reaches to dangerously high speed. This is the answer at no load condition. Sir, if it is connected at loaded condition, if the field winding is open circuited, then what happens, sir? In loaded condition, this is the torque phi into Ia. If this is reduces to 0, in order to maintain constant load, the armature current increases to very high extent. Then what happens, sir? What happened? Armature winding gets burned. This is generally under loaded condition, under no load condition, if the field winding open circuited. Right? Next one, second one. For example, if field winding short circuited, then what happened? When the field winding short circuited like this is connected, bypassed. When the field winding short circuited, the current through the armature is 0. The total current chooses the short circuit path. The total current is equals to short circuit current. If there is no current in the armature, then there is no speed in the armature. There is no analysis. This is the second question. And third question, if armature winding open circuited or short circuited. If the armature winding open circuited, there is no Ia, there is no armature current, hence the speed is 0. That's it. Nothing but if the armature winding open circuited, Ia is equals to 0. If there is no Ia, there is no speed. For example, if the armature winding short circuited like this, there is no current into the armature. If the armature winding short circuited, no armature current, then the speed comes to 0. This is simply about the DC shunt motor analysis. For example, if the same question take for compound motors. Okay, let's go for compound motors. The same concept for compound motors, that is very important actually compared to this one. In this concept, compound motors are very important. They may ask you question. See here, I am taking cumulative compound motor. They not mention nothing but the phi SH is greater than phi SE. Okay, alright. Let's see how it is. For example, take the long shunt. It is like this. Yes. This is my long shunt cumulative compound motor. When this is cumulative compound, here we have a armature winding is like this. Now this is my armature current, this is my series field current, this is my shunt field current. Cumulative, that's why phi is equals to phi sh plus phi se. Right. Now first question. If armature winding open circuited or short circuited. If the armature winding open circuited or short circuited, armature current 0, then speed 0. It's clear. Now the second question. If series field winding, what happens, sir? Series field winding open circuited. If the series field winding open circuited, armature current 0, then the speed 0. If the series field winding open circuited. This is clear, right? Next one. If series field winding short circuited. When the series field winding short circuited, then what about phi se? Phi se is 0. If the phi se is 0, what is the total flux? Phi is equals to only phi sh. Nothing but the total flux decreases and the speed increases. How much increases? Slightly, just slightly, because phi se is a small value. This is small decrement in flux. Then small decrement in flux leads to small increment in the speed. This is simply the next concept. When the field winding short circuited. Simply, when the series field winding short circuited, machine act as a DC shunt motor. You should remember this one, don't forget. This is the question. What happened if the series field winding open circuited or short circuited? What happened? Now the next question. Now the fourth question. If the shunt field winding open circuited, when the shunt field winding open circuited, how the machine act as a? The machine act as a series motor, no problem with that. If it is at a no load condition, when the shunt field winding open circuited, what is the flux actually? Flux is equals to phi sh plus phi se, nothing but the total flux reduces in large, not small, large reduction. If the flux is in large reduction, then the speed is in large increase, nothing but dangerously high speed. You know that series motor under no load condition, dangerously high speed. We know already about this. But in the examination, when they ask the question like this, you are thinking like a Einstein. What we have to do? We have to write a new book for this new question. Huh? This is not a new question. This is already old question. This is already old concept. Right? Right, sir. This is at no load condition. Next, at loaded condition. At loaded condition, when the flux decrement is large, then what happened? The load torque directly proportional to phi into Ia. When the flux decrement is large, to maintain the constant torque, armature current increase also large. When the armature current increment is large, what happens, sir? Armature winding says, I'm sorry. Armature winding says what? I'm sorry. Right? So armature winding burns out. This is when the field winding, shunt field winding, open circuited on this concept. Right? For example, in the fifth case, shunt field winding short circuited. If the shunt field winding short circuited, what is armature current? 0. If the armature current 0, then what happened? Speed 0. If the shunt field winding short circuited, there is no operation. because the speed is equals to 0. This is the concept on cumulative compound motor when it is the different types of windings open circuited or short circuited like that. Are you clear? Right? If the same question asked for, they mentioned that phi sh is less than phi se or my phi se is greater than phi sh, then what happened? Even though if the armature winding open or shorted, this one only. If the field winding open or open, this one only. If the field winding open, nothing will happen. If the field winding, if the series field winding short circuited, it is act as a shunt motor, of course. Of course, my phi se is 0. When my phi se is 0, we have only phi sh. When we have only phi sh, what happened? Here flux decrement is large reduction, because this phi se is a maximum value. My maximum value is 0. When my maximum value is 0, here large reduction, here large increment, which leads to dangerously high speed. You should remember this one. This is goes to dangerously high speed. When this goes to dangerously high speed is like that. Very, very, very important. And next one, when the field winding short circuited, the analysis is same, no doubt at all. If the field winding is short circuited, there is no analysis. Now we have to analyze this one. Now this one. What will change? This is already change is there. I read about that change. This is same, this is same, this is same. So this is changed. I know what changed. And this is also changed. Let's see. When the shunt field winding open circuited, this is act as a series motor, of course. Under no load condition, here this is a small decrement. When the flux decreases a small, then what happens are the speed also small increment. Speed increment small. And under loaded condition, here the flux reduction is small. So when the flux reduction is small, then the armature current also increase in small extent. Here armature winding doesn't burn, but it may lead to increase in temperature somewhat. Just the temperature increases, that's it, but doesn't happen in this case. This is in that only the second case, when phi se is less than, when phi sh is less than phi se. Right? This is the questions they are asking. Now, here very important thing is that the next question, what is that? Differential compound motor. This is very important actually. Comparatively, we have to analyze must and should. Because in all these cases, the flux is initially positive, even here also positive, even here also positive. There is no change in flux direction. If there is no change in flux direction, there is no changes in speed direction. But only the case which is differential compound motor, in this case flux will change. That's why this is important. Are you ready? Ready? Right. Let's see, sir. Now we are going to see the differential compound motor, a long shunt differential compound motor. So let's see what happened to each and every case. Let's see what happened to each and every case. Let's see carefully. This is very important, sir. Don't confuse. First case. If the armature winding open circuited or short circuited, what happened? If the armature winding open circuited or short circuited, if the series field winding open circuited, in these two cases, and if the shunt field winding, this is actually the third, we have to take here. And the third case is, if shunt field winding short circuited, in these three cases, what happened? Armature current 0 and the speed 0, no analysis, maximum part completed. Now we have only two cases. One case is that First of all, if series field winding short circuited, what happened? If the series field winding short circuited, then what happened, sir? Tell me. Phi SE is equals to 0. Then the flux is equals to only phi SH. Only phi SH, nothing but the maximum quantity. The minimum quantity is 0. Nothing but the total flux reduced or increased. For example, this is a 10, now this is 1. Actually flux 9. But when here this is 0, what is the flux? 10. So the flux increment in small extent. When the flux increment in small extent, the small decrement in small, the speed decrement in small extent. Right? This is the question. When the series field winding short circuited, it's very clear, crystal clear. Now the next one, very important in this case, see here. Here the flux is even though positive and armature current also even though positive, hence torque also even though positive, hence the machine rotates in same direction. Same direction. There is no case of reverse direction up to now. But see in this case, if shunt field winding open circuited or short circuited, open circuited, this is the special case which we have to go through, must and should. Right. When the shunt field winding open circuited, what is ISH? ISH 0. If the ISH 0, what is phi SH? Phi SH also 0, which is the maximum quantity. When the phi SH is 0, what is phi? The phi is equals to, tell me what is the phi? 0 minus phi SE, nothing but the flux is a negative value. You should remember this one. And here in first case, at no load condition, when this is open circuited, the motor acts as a series motor. When this is a series motor at no load condition, what happens are here? The flux decrement is large extent, yes or no? The maximum value 0. When the flux decrement is large extent, then speed is dangerously high speed. When same direction or negative direction? Tell me, same direction or negative direction? The torque directly proportional to flux into IA. IA same but flux negative. When the flux negative, torque also negative. When the torque negative, this rotates in opposite direction. This rotates in opposite direction. This is the no load case. Of course, up to now we have same direction, but now we got a negative direction of answer. Yes, sir. Here in shunt field winding, the speed, when the shunt field winding open circuited, speed is dangerously high speed, but in which direction? Opposite direction. Under loaded condition, what happens, sir? Second one, at loaded condition, torque directly proportional to phi into Ia, the flux is more, hence the armature current is more. Then after what happens, sir? Armature winding gets burns. This is simply the shunt field winding open circuited. And here where is when the series field winding short circuited? Is there series field winding short circuited? Then the machine acts as a shunt motor, of course. Right? This is simply the question on differential compound motor when the field winding open circuited or short circuited, like that. So these are the concepts on this DC motor, the special concepts. In that, the first one I said you motor and generator direction. The second one I said you when the supply terminals are reversed for motor. And next one when the prime mover direction is reversed for generator. And next one when the prime mover is disconnected. And next fifth concept is that when the armature winding open circuited, field winding short circuited, and series field winding open circuited, what is the speed, what is the direction? Like that they will ask you questions. This is simply what the special cases in our DC machines. Right? Thank you.